Hello, welcome to Chapter 4.3, Part 1, Greatest Common Factor. The greatest common factor, GCF, of a group of natural numbers is the largest number that is a factor of all the numbers in the group. There are different methods which can be utilized to find the prime factorization of a number. One way is to make a factor tree. Another is to repeatedly divide by prime numbers. Example 1. Find the greatest common factor of 120 and 96 using a factor tree. So we're going to make a factor tree for 120. So that means we're going to break 120 into factors, 10, 12, let's say, and we're going to continue to factor it until we can factor no longer. So in this case, we have 10 and 12, and we can factor 10 further into 2 and 5. But we cannot factor 2 or 5 any further except factoring one end itself. For 12, we can factor further into 4 and 3. We have to stop at 3, but 4 can be factored into 2 times 2. So that means in order to get 120, that would be 2 times 2 times 2 times 3 times 5, and that will give us 120. The factor tree for 96. Well, 96, we can factor that into 8 and 12. We can further factor 8 into 4 and 2. We have to stop at the 2 because the 2 can no longer be factored except for 1 and itself, but the 4 can be further factored into 2 times 2. The 12 can be factored into 4 times 3, but the 3 cannot be factored any further except for 3 and itself. But the 4 can be factored into 2 times 2. That means that 2 times 2 times 2 times 2 times 2 times 3 will give us 96. We multiply the factors they have in common. And in this case, the factors they have in common, both of them have 3 2's and both of them have 1 3 as indicated in blue. So we have 2 times 2 times 2 times 3, and that will give us 24, and that is the greatest common factor. In example number 2, we're asked to find the greatest common factor of 120 and 96 using the list method. And this means we're going to make a list of all the factors of 120 and 96. So I list all the factors of 120 that are possible. 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. And I do the same for 96. 1, 2, 3, 4, 6, 8, 12, 6, 24, 32, 48, 96. I look for the largest number both lists have in common. And in this case, it's 24. That is the largest number that both lists have in common. Therefore, the greatest common factor of 120 and 96 is 24. In example number 3, we're asked to find the greatest common factor of 120 and 96 dividing by prime numbers method. So here we're going to divide 120 by prime numbers. So we're going to start by 2. So 120 divided by 2 is 60. Then we're going to take 60 and divide that by 2 and we get 30. We'll take 30 and divide it by 2 and get 15. But we can't divide 15 by 2, so we go to the next prime number. And in this case, it's 3. So we look at 15 divided by 3, and indeed, 15 does divide by 3, and we get 5. And then we have 5, but 5 does not divide by 3, so we go to the next prime number, which is 5, and 5 divides into 5, which is 1. Similarly, we do this for 96. We take 96 divided by 2, and we get 48. Then 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. But 2 cannot divide into 3, so we go to the next prime number, which is 3, and 3 divides into 3 once. We then list all the prime numbers that we divided each one by. In the case of 120, we have 2 times 2 times 2 times 3 times 5, and that will give us 120. And in the case of 96, we have 2 times 2 times 2 times 2 times 2 times 3, and that will give us 96. We multiply the factors they have in common. In this case, I mark them in blue, and we get 2 times 2 times 2 times 3 is equal to 24, since they both have 3 2's in common and 1 3 in common. The next method we're going to do is finding the greatest common factor by dividing by prime factors method. So step 1, we write the numbers in a row. Step 2, we divide each of the numbers by a common prime factor. We try 2, then 3, and so on. Step 4, we divide the quotients by a common prime factor. We continue this process until no prime factors will divide into all the quotients. Step 4, the product of the primes in steps 1 and 2 is the greatest common factor. So let's look at an example dividing by prime factors method. Here we're going to find the greatest common factor of 12, 18, and 30. So in order to do this, we make a little division thing underneath 12, 18, and 30, and we divide 2 into 12, 18, and 30, and we see that 2 goes into 12 6 times, 2 goes into 18 9 times, 2 goes into 30 15 times. But we can't go further with 2 because 2 does not go into 16 or 9. So let's try 3. And we find that when we divide 6 by 3, we get 2. 9 divided by 3, we get 3. And 15 divided by 3, we get 5. But we cannot go any further. No common factors. So since there are no common factors in the last row, the greatest common factor is what is over here, which is 2 times 3, and that means our greatest common factor is 6. The next method we're going to learn is the Euclidean algorithm, and we're going to learn how to find the greatest common factor using the Euclidean algorithm. Step 1. To find the greatest common factor of two unequal numbers, divide the larger by the smaller. Step 2. Note the remainder and divide the previous divisor by this remainder. Step 3. Continue the process until a remainder of 0 is obtained. Step 4. The greatest common factor is the last positive remainder in this process. In example number 5, we're going to use the Euclidean algorithm to find the greatest common factor of 120 and 96. For this one, I'm going to go over to the whiteboard and work this one out. In example number 5, I'm asked to find the greatest common factor of 120 and 96. What I'm going to do is I'm going to divide the smaller number into the larger number. That means I'm going to divide 96 into 120. And I see that only goes into it once. So I'm going to put 96 down here, and I'm going to subtract, and I end up with 24. I'm going to divide 24 into the previous divisor, which is 96. So that means I'm going to take 24 and I'm going to divide it into 96. And it turns out 24 goes into 96 4 times, and that gives us 96 with a remainder of 0. The last positive remainder here is 24, and that is the greatest common factor using the Euclidean algorithm. Reviewing what I just did on the whiteboard, I first divided the smaller number into the larger number, in this case 96 into 120, and it went in one time, and I subtracted 96 from 120 and I got 24, and 24 was my remainder. Then I took 24 and I divided it into 96, and 24 went into 96 4 times. 24 times 4 is 96, and then I subtracted 96 from 96 and I got 0. 24 was my last remainder, so that means the greatest common factor of 120 and 96 is 24, like we found using the other methods. In example number 6, we're asked to use the Euclidean algorithm to find the greatest common factor of 60 and 168. So let us go over to the whiteboard and work this one out. In example number 6, we're asked to find the greatest common factor of 60 and 168. So we're going to divide the smaller one into the bigger one. So that means we're going to divide 60 into 168. And that goes in 2 times. So that's 120. And we're going to subtract that. And we end up with 48. Now we're going to divide the divisor, which is 60, by the remainder, which is 48. So that means we're going to have 48 divided into 60, and that only goes into 60 one time. So we have 48, and we subtract, and we get 12. And 12 is our remainder. So we go through the same process, but this time we have 12 as our remainder, and 48 was our previous divisor. So 12 goes into 48 4 times, and 4 times 12 is 48, so we end up with 0. This means that our last positive remainder is our greatest common factor. Reviewing what we just did on the whiteboard, I divided 60 into 168, and 60 goes into 168 2 times, so that 2 times 60 is 120. I subtracted it, I got 48. That is my remainder. Then I took 48 and I divided it into 60. It only goes in once, and I subtracted 48 from 60 and I got 12. Then I took 12 and divided it into 48, and I found that 12 goes into 48 4 times, and 4 times 12 is 48, so when I subtracted the two, I got 0. Thus, my greatest common factor is 12, since 12 was my last remainder. My greatest common factor of 60 and 168 is 12. Notes about finding the greatest common factor. There are other methods to find the greatest common factor, but these are the main ones. For all these algorithms, it is important that there are no remainders at the end. Otherwise, the greatest common factor is 1. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.